Okay, so we're continuing on with stoichiometry. This time we're going to talk about gas stoichiometry, and these are all at what we call STP, standard temperature and pressure. So as long as it's all at STP, standard temperature and pressure, then we're going to use this conversion factor down here, which we learned when we learned about moles, is 1 mole equals 22.4 liters at STP. If we changed temperature and pressure, then this would no longer be true. But for all of ours, that's going to be true. We're going to be using these four on our cheat sheet. Let's just talk about liters to liters. What's different on this, though, is we don't have a balanced equation, so you need to go balance these equations first. If you weren't with me first semester to learn how to balance equations, please talk to me. All right, so if we need to balance an equation, that means we need the same amount of atoms on both sides of the equation. So here we've got carbon and oxygen, and I'm going to count these up. I've got 1 carbon on the left, 1 on the right, but on my oxygen, I've got 3 oxygen on the left and 2 on the right. Okay, remember that's an understood one there. So that's not going to work. I need even numbers for balancing, so I'm going to change that coefficient to a 2. So now I've got 2 oxygen here plus the 2 here, so I've got 4 oxygen. So now it's easier to balance because I know what I need to do. I need to get 4 oxygen over here, so 2 times 2 is 4, and now I've got 2 carbon there, and when I put that 2 there, I have 2 carbon there. So I've got the same amount on both sides. So now I have my coefficients that I need to do my stoichiometry problem. All right, so I balance the equation. B says if I have 1 liter of carbon monoxide, so I've got 1 liter of carbon monoxide. Let's remember carbon monoxide, CO. So that's what I know. I'm going to give that the X. Reacts with oxygen at STP, standard temperature and pressure. How many liters of oxygen are required to react? So oxygen is going to be my Y. I'm going to put a Y there. Can you see my X and Y? So again, I've assigned X, I've assigned Y. I want to know liters, and I know liters. So it's a liters to liters problem. All right? So if I go down here to my cheat sheet, it's just like moles to moles. I'm going to set it up the same way. So I'm going to start with 1 liter of carbon monoxide, and I need to cancel with liters of carbon monoxide. But because I'm going to have that 1 mole over 22.4, I can just kind of do a shortcut here, and I'm going to go straight to liters to liters. Okay, I'm going to have liters of oxygen as my Y, and liters of carbon monoxide as my X. Okay, so here's what's happening. I just need to get my coefficient in front of my Y, which is a 1, over my coefficient in front of my X. So it's a 1 to 2 ratio, mole ratio, and I'm ready to calculate 1 times 1 is 1, divided by 2 is 0.5 liters of what? Liters of oxygen gas. So there's my answer for number 1. All right, on C, well, that was 1B, right? On 1C, how many liters of carbon dioxide is produced? So that was my first Y. So my next Y is going to be this CO2, carbon dioxide. So I have the same X, but a different Y. So this part is going to be the same, but now I've got a different Y. I've got CO2. What's in front of CO2? A 2. So I'm ready to calculate. 1 times 2 is 2, divided by 2 is 1. So I've got 1 liter of carbon dioxide because those cancel out. Okay, so I have 3 different answers here. The balancing, and I've got these 2 answers here. So on number 2, this is a hard one to balance. I'm going to help you out by telling you the first coefficient here is a 2. See if that you can balance it out. Okay, so balancing is A. Then you'll do a liters to liters problem for B, C, and D. So you're going to have X1, X2, X3. So in the first one, it says how many liters of C2H2, so that will be, oh, I meant Y1, Y2, Y3. This one says what volume of water, so that's going to be Y2, and then what volume of oxygen, so that'll be Y3. Okay, so what do we know? So X is going to be this CO2. See if you can balance that out, though. If not, I will help you out on that. Liters to liters. When you get down here to number 3, that's when it starts switching around, and we're going to work on some of these other ones. But it's just like what we did up here with the grams to moles and moles to grams. We're going to do liters to moles, liters to grams, and grams to liters. Okay, follow along with your cheat sheet. Okay, pick out your X and Y's. If you have any questions, let me know.